Hello, everyone. Welcome to Roslav. Sorry, I'm not Aaron Pedersen. I'm not good at puns, but I thought this was so funny. I had to put it in my presentation. And I'm not gonna start the presentation as usual with drunk photos. I'm gonna start with this beautiful backdrop that I created with GIMP on Linux, not on macOS. As you can see, I'm quite talented now with like fonts and stuff. It looks pretty cool. So I'm not going to show Andre in underpants. I'm not going to show anyone drunk from last night. I'm going to tell you. So I learned how to eat tartar in Poland. It's basically you mix two of the most dangerous things in the world raw, like raw meat and raw egg, and then you put stuff on top, and then you mix it, and it's delicious. Welcome to Poland. And what it takes is an extremely talented Polish person to put salt and pepper on top in a specific way. That's how you eat tartar. So today I had this and it was great. I'm feeling amazing. I want to draw your what? No, it wasn't that salty because I already had a salty breakfast, which it was a salt. Was that a pun? Hey, come on stage. So I want to draw your attention to my beautiful backdrop again, because I'm so proud of it. Took me like 10 minutes to get the scaling and everything, but yeah, whatever. So lots of people were laughing, saying, ha, Nick Sutterer is coming, he doesn't have a talk title, he's probably going to talk about Trailblazer. It's like super surprising that people talk about their projects when they're invited to conferences. I'm not going to talk about Trailblazer. This slide is only to remind me, I have stickers and lanyards, pretty cool, for Trailblazer, so if you like Trailblazer, if you hate Trailblazer, just come get a sticker and I don't know, like burn it on camera or something like that. Again, like look at this. Like, okay, so today is a beautiful day. It's Saturday, I guess. So I'm planning to walk you through my life from basically day one of my programming career, if you can call it career, to today. Which I'm trying to explain how I how my programming style changed from like the stuff we learn in like books and so on to stuff we were just discussing in the panel with like event sourcing and components and all this kind of stuff. So when people ask me when I started programming, I always say I was 8 because it sounds cool. I have no idea when I started programming, but this is my friends and myself. Can you spot me? Like this is me about 8 years old or something. So that's when I started programming officially. So my first programming book was a book called Tricks of the Mac Game Programming Gurus. Back then I thought it's pronounced gurus, but that was because I didn't speak English. And so I wanted to start programming to program my own game basically. And I was using a Mac before it was cool. And this book was basically teaching programming on Mac. And I remember exactly that I learned like C++ with a different book, and I was really struggling with like I loved the concept of a function. I kind of got the idea, but I didn't understand why you can like you have the parameter like int a and int b, and then you use a and b in that function. But when you call that function, the a and b can have different names. For example, var a or something like that in my example. So I was talking to my dad. And he kind of explained to me like, hey man, just think of a function as a component you call and you throw in the arguments or like the values you want to process, and the implementer of the function, like myself, you don't care about how that variable is called on the outside. So that's kind of how I understood. Okay, a in my function can actually be called variable from another planet in the in the calling code. So and that was kind of for me that was like a traumatic event in a positive way. So I kind of understood, hey cool, so I can use functions to encapsulate behavior, and the outside world doesn't know what I'm doing in that function because I can name my variables the way I want, and the outside world doesn't know about it. And I don't give a shit about how the outside world, the caller, is processing variables, because I can like it's just two different components. And so I took that stuff from C++, my C++ code. Like I didn't know what I was doing. Like really, I was just copying stuff from C++ books to C++ compilers. I don't know the name anymore, but and it worked. So, but I love the idea of functions, and I took this to Perl because I started programming Perl. This was the actual first programming book. You should all read it. Not. And from Perl, I learned programming, and then I started to use Ruby on Rails and Ruby. And I was instantly unsatisfied with the way functions, and encapsulation was handled in Rails. Not in Ruby. Ruby has functions, Ruby has methods, Ruby has all this kind of stuff. But in Rails, it was always like, I don't know, there was one big thing handling everything. So I started Rails, and it was like absolutely amazing. But I was struggling to find the architectural ideas behind it. And so I started writing my first gem called Cells. And what Cells did was super simple. Like you have like a huge web page. This is Amazon. This is not, I didn't write Amazon. So for example, you have a sidebar, and you want to have that sidebar on every page. So in Rails, the only way was like a partial and controller and before filter, and you share logic in the controller and all this kind of stuff. So basically, I wanted to have a class, like this. So don't worry about the actual code. So basically, I wanted to have this in an object, and that object, exactly like a function, doesn't know what's happening on the outside, and the outside doesn't know what's happening in the cell. So I kind of wrote this blah blah blah, cell gem, and you had like a class, and the class could be rendered with a helper. So you said render cell, and then it would call that function, and a partial or a sidebar or an entire page would be rendered, and the rendering didn't know anything about the other rendering. And what was pretty awesome was that you could do that, you could test that stuff in isolation. So I could render my cell, and it would do exactly what it will do in production, because I had to pass in the dependencies, and I got out HTML as a HTML string. That was pretty cool. And the cool thing is, DH8 liked it. So he that was like in 2008 or something. Let me check 2008. So he emailed me like, hey, this is actually a cool idea. And so he liked the idea of encapsulation. So just to remind you, that's the same guy who now tells everyone that concerns are a great idea, and you should push as much code as possible into one class called the model in Rails. And so he liked it. I was pretty proud of myself, and nothing ever happened after this. So so the next problem I was approaching was reform. So I kind of had the idea, hey, there's a form in a web UI. Why the hell would I have this form in my models and stuff? Like, why don't I let's introduce a new class for that model, and that class is only mapping to that form you just saw. So you define properties, you can define collections, blah 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 blah. You can define validations only for that form, like contextual validation in a class. And the cool thing was, you could test that in isolation again, and you wouldn't know what is happening inside, and the inside wouldn't know what's happening outside. And the cool thing is that you can test that without having to run a fucking HTTP request. Sorry for my swear words. I'm already aggressive. So GHH liked it, kind of. Okay, he kind of so we had this chat on via email again, and he said, hey, I can see how this is helpful, and actually I don't like accepts nested attributes. I forgot the for. So I'm still wondering why do we have it in Rails if they don't like it. But yeah, it's cool to have features and push them into the society, and people think it's good, but it's bad. Anyway, so I kind of worked with Rails, and I kind of I wrote some gems and stuff, and I didn't really see why are we making our life so difficult with this monolithic thinking, like one controller for everything, and my code sits in the model, and the model is an object, and where are the boundaries? No idea, because it's cool, it's just fast, and you can build Basecamp, and you can make millions of dollars if you're good at it. I'm not good at it. This is why I'm still here. Whatever. So the problem was that I introduced objects, and I introduced encapsulation, but we still had this problem of, now I have those objects, now I have my scope, but how do I tweak those objects? How to customize them? Like a cell is a cell, but if you want to have another cell for, I don't know, for Christmas with a different theme, how do you customize it? If you have a new form with a different validation, how do you do that? And you always like since you have an object, you have to in Ruby you have to use inheritance or beautiful mix-ins, and you just use the mechanics that we have in Ruby, because Ruby hasn't changed in more than 10 years or 20 years. So we always use like extend and super, and you override methods. I'm going to talk about this in a little bit. And you kind of have really low level, when I say low level now, I mean low level, like mechanics to customize objects. So we have objects now, which is great, but we're still struggling to customize them. And then they introduced refinements. I'm 100% sure no one in this room has ever used refinements, because they are so fucking hard to understand, and like no one knows what they do. And come on, raise your hand. Oh my goodness, I'm leaving. Give me a drink. So yeah, so refinements was a nice idea, but it didn't work. So it's like customizing objects at runtime and or compile time. We don't have that concept in Ruby yet. And so I stood on a mountain with a glove in my hands, and I like looking towards the horizon. The sun was rising. And so what do you do when you're unhappy with something? You write your own framework, of course, because you can. That's a great tool on the web. You can do like your own cover. And by the way, I'm not going to talk 30 minutes. I'm going to talk longer. So the idea was, so I had the cells and reform and all this blah 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 blah. So I kind of started. Okay, now let's focus on business logic. Like, how do we get rid of really big controllers? How do we get rid of like models that are you doing your drugs again? This guy, right? So. So I started to think about, let's make controllers great again. And I started to introduce this concept called operation. So in a controller, instead of having like 500 lines of code, you would just delegate to a specific object. We call it operation. And it's from this gem called Trailblazer. So if you look at it, you really only call a function again. Like it's the same concept as we have with a cell or with a form object or something like that. You call an object and that object does something. And it's not like crazy, it's just have responsibilities scoped, okay? And so the operation was well accepted, but lots of people thought it's like a monolithic object and it does too many things, and it's basically just an object delegating to other objects. So it's an orchestrator, yeah? And here's like an example of in Trailblazer 1.1, the object was doing lots of stuff, and with this big DSL, and like you had the process method, and in the process method you would do your business logic, and like creating a model and validating and all this kind of stuff. The cool thing was you could test it in isolation. It's great. And when you have objects, you can actually test them without having to run an entire HTTP stack. And that's why I like testing in DHH. It doesn't. So you could run this operation, test it, test the outcome, test the side effects, done. And this stuff will work exactly the same way in production. You could also use operations as a factory. So if I want to create a comment the way it's done in my web application, I run the operation that does that, and I have the exact same application state in my test, which is amazing, because factory girl is an approach to make your test state like your application state, but it's not because you forgot about the isAdmin flag or something like that. So you run that operation, everything is exactly as it is in production. The problem was in 1.1, we had this process method. And in that method, you would write your Ruby code, like literal Ruby code. And if you had lots of logic, you had to split it up into methods and classes, and it was all up to you. So the idea of Trailblazer 1.1 was you run this object, and everything behind that is up to you. And it was a nightmare, because you had to know the exact call stack, yeah? I mean, you don't have to understand all the methods, but like when you run an object, there will be methods called, and methods calling methods, and method, and if you want to override something specific, for example, there was always a policy check run automatically in an operation, yeah? Like, is this user allowed to create a comment? And you had to know where this happens, and what is the call stack, and what method do you have to override, and then your own code would be run in the process method, and again you had this call stack, and you had to know where what is called or how, and it was super messy. Like if you wanted to override specific behavior, for example, hey, in that case I don't want to run a policy, you had to override the check policy method, but you had to know that it's called check policy with a bash, and you had to know where, and it was just horrible, yeah? So the example with the policy is right here. Like if you override something, you have to inherit. Yeah, so I'm inheriting, and I'm overriding. Actually, this is complete bullshit. No, whatever. So So you have to override that specific method because you have to know that method exists in that class and is called at that point. And then you can do stuff like you call it super, and super will call the original implementation. But it only works if you include a module, because if you don't include a module, it's whatever. It's like super messy. And like I started to realize, hey, maybe Ruby doesn't give me the tools out of the box I need. You know, like if I want to have workflows and I want to be able to override specific parts, maybe I need a different tool set. Yeah, and this was especially funny if you had like multiple modules included and they would all override the same method, and you know, like the last included module overrides the method, and then if you call super, it will call the other method before. And if you want to skip something, for example, it's impossible in Ruby. You can't say, let's call the original method and the method from the third module included. So it's just bullshit, basically. But these are the mechanics Ruby gives us, and it's I'm not blaming Ruby, I'm blaming my bad design choice, basically. Yeah? And every time I talk to people, they all told me, this is Ruby, this is how you do it, and just do it like that. You know, modules are awesome, inheritance is great. Do it. Like, this is what we have. Like, this is how we do it. Okay. So I kept moving on. So the idea in Trailblazer was have those operations. You call them. There's no other way to invoke them. You call basically a function. And the function will delegate to different other stakeholder objects without knowing what they do again. Like it's encapsulation. Well, like some people from Rails don't know this. And then the problem was we had this call stack. You had to know what is happening in the operation. It was really hard to communicate that. You had to document that shit, and documentation sucks. And so you always had this object floating around, and people could call methods on the operation instance in the wrong order, and it was just terrible. The fucking cool thing was DHH liked it. Not! I didn't paste the email he sent me, but it's okay. So, so did I already mention I'm going to talk more than 30 minutes? That's great. So I kept, working with code, and I hated the call stack, and I hated to use super and modules to override stuff and to know what operation does in what order and this kind of. Hey, didn't you promise me to give me a beer in my talk? Here we go. So I slowly moved into the direction of functional programming. Like I realized, hey, maybe object-oriented programming. Maybe I just hit the boundaries. Maybe my style of writing software is not. It's warm, right? Okay, open it, please. So so I kind of left the thinking of object-oriented programming. Actually, Piotr Solnitsa, one of my great inspirations, kind of nudged me to that direction. Did I tell you that I can say two things in Polish? One thing is Piotr Solnitsa, the other one is Pine Pierdol. Cheers. Oh, delicious. So I kind of moved into the direction of functional programming is nothing, crazy or something. You just call something and it does something and it gives you something back, yeah? So basically you throw arguments into an object or into an object method in that case, in Ruby, because we don't have like functions, and this function does something, gives you something back. And that was basically what we already had with Trailblazer. Like you call an operation, there's no way, like calling an operation with the dot bracket, which looks really weird, but it's basically like calling a function, yeah? And you had your input, and you throw that into the operation, and you get a result back, and we just defined that the result has a state, successful or not successful, and the result also allows you to access state that comes out of the function. Yeah? Like the output of the function is basically accessible via the result object. So the idea was already kind of functional. I didn't realize it, but my great inspiration, Piotr Solnitsa, made me aware of it. So what we wanted to get rid of in Trailblazer 2.0 was that this call stack mess that we had, I wanted to get rid of that. And so basically what we did is, instead of letting the user define their methods and call, we gave them a DSL that allows them to define workflows. Yeah. So for example, like you have like pass and step and fail and blah 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 blah. So in the end of the day, what you will get is a diagram or a flow like this. Like you look at it and you know exactly what's happening. I don't have to explain it, right? Because everyone here is really smart. So without the details. So what inspired me to kind of come up with that DSL is I didn't invent it because I'm not smart. I'm just stealing a lot of ideas and put them in my own jams, and then I say Nick Sutterer, and it's like not a thing. So I stole that from what's that? Railway-oriented programming, exactly. So that's a functional pattern from .NET Community. Microsoft. Ooh. Hey, really? Oh. So thank you, Microsoft. So the railway-oriented programming is basically you define 2 tracks, and then you run logic, and if something like fails in a certain step, it jumps to the left track, to the error track, and nothing of the right track is executed anymore. So it kind of stops the execution and goes to the error handling. And you can have as many tracks, as many steps on each track as you want. Yeah, this is kind of a beautiful illustration. Again, my gym skills are amazing. I also use LibreOffice for this, and it took me like 20 minutes to to prepare this. Wait, should we look at it again, like just because it's so beautiful? Okay, so you call this operation, this railway animation is running, and you can ask the result, hey, were you successful, meaning you ended on the upper track, or were you not successful, meaning you ended on the lower track, and you can ask the result for a state from the inside. So I'm going to talk about this in a second. So that was kind of the idea, and the DSL, you can like it or you can not like it, but it was kind of, people kind of started accepting it. Okay, that's pretty cool. You can define workflows without having to know how to wire Ruby functions together and without calling them manually. So every step in Trailblazer is a callable object or an instance method. So I'm only showing the instance method because it's the easiest to understand. You just define every step as a method. The step gets a context object and keyword arguments from the outside, and basically what you do in that step is up to you, but you write state to the context object, and that is exactly what you will retrieve in the end in the result object. Yeah, so there's no instance variables, no like weird global variables. You write to the context object, and then you can ask the context object for that state you wrote in on the inside. Yeah, so that's the only way to communicate with the outer world in an operation, and it's a concept that was really well accepted in the community, basically. The other thing is, depending on the result of a state, true or false means true, we stay on the right, on the successful track, on the upper track. False means you jump to the lower track. Remember my beautiful animation. The thing is that we also allowed to do compositions. Yeah, so you can nest those operations, and lots of people started overusing. I mean, it's great to use composition, but I wasn't aware that people love composition, which is amazing. Like, people used the nesting feature everywhere, so they built reusable components and use the reusable components in every operation. So basically, by using nested, you kind of build a composition. And when you use nested, what happens is basically this is the nested activity that is being run, and so the nesting operation calls that activity, and then you can wire the ends of that nested activity to different connections and kind of process different outcomes in a different way. So this is all like blah, blah, blah. Look at this picture, you see lots of arrows, is great. So again, we had functions, which are operations and steps, and the only writable or mutable object was this context object that we pass through all those steps. And if you have compositions, you pass in the same context object, and operations can write to that context object, and the only way to communicate is via that context object. So that was pretty well received. But this is just a normal JPEG. I just copied it, so it didn't take me longer than 15 seconds to prepare. I'm not good at 3D modeling. So what we also allowed people, and this is kind of the learning from, overriding methods with modules and calling super, is like, now that we have this beautiful structuring in steps, let's allow people, for example, to exchange a step. Like, I'm gonna replace notify admin with another step called mail. So you had to subclass it, and you can use the replace option and replace a certain step. Like, impossible in Ruby with super or something like that. You can't replace something specific. Or you can do stuff like inserting a step with the like, just by using the DSL and saying after blah 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 or before blah blah blah, you could add steps to that workflow in a subclass without interfering with original code. Again, almost impossible in Ruby unless you use like include in the right order, and it's just a nightmare. What's that? Prepend, yeah. Exactly, but prepend is again a feature no one uses in Ruby. I don't know what. I'm wrong. Hey, let's talk about event sourcing. So another thing you could do is, for example, you could delete, and now you come with your prepend, and there's no way. Like in Ruby, you can't delete a method that is in a specified workflow. In Trailblazer, you could just say, okay, delete that last step in my subclass with the delete option, just as an example. And so you basically, so you have all the mechanics to rearrange a workflow, to customize a workflow out of the box. So we didn't have this nightmare of including objects, modules and all this kind of stuff. Yeah. Many people appreciated it, and lots of people said, how can you come up with this kind of stuff? Like, we have Ruby, I want to be my own, I want to be in control of my workflows, don't do this. We have Ruby, we have been writing Ruby the way we were writing it since 2001. How can you introduce this kind of stuff? That was the ranting session. Also, there were people who were asking for more features, because once you give them food, they will ask for more food. So, for example, people ask, hey, let's give us tracing or something. We want to know, did that way, or did we go that way, or did we go that way? And, or did we go that way? So people asked for like a feature called tracing. And it sounds like, hilarious, but I mean, the feature itself is amazing, like, for debugging and for reconstructing. But it was really hard to kind of change the internals to make that stuff happen. So in 2.0, we still had this call style. Actually, it's wrong because there should be a dot between create and the bracket, but whatever. So we introduced the DSL to make workflows defining the diagrams simpler. And we still had this concept of you throw something into the operation, and the operation calls different steps, but the steps don't know what the operation is doing, and so on. Like functional information hiding, basically. And the most amazing feature was that you could also push, like you could use the developer gem and throw in an operation, and the operation would be rendered as a diagram automatically, which was pretty cool because people didn't have to understand what the operation does. They just look at the diagram. I'm better at visual stuff than at non-visual stuff. So people, this guy is basically asking me, why are you being an asshole, you idiot? Why did you change the API from 1.1 to 2.0? And I said, because I can. Like, people were really angry with me, like, hey, how can you change the API? Like, it's and it's like a major version and semantic versioning and blah. And I'm like, yeah, that's exactly the point of a major version release, right? That you change the API, whatever. So people don't like innovation. Please stay the same way you have always been, the same way that Rails does it and hasn't changed for 10 years. It's great. Okay, let me drink a sip of this beautiful Vojovnik. Okay, so we had the 2.0 version was kind of well received. Lots of people were using it. They liked the way they can structure the stuff. And the first thing we did in 2.1 is we gave them tracing, so they basically could see, okay, this and that happened when I run a specific operation, which was a pretty cool feature. And we also gave them the ability to, have different workflows, not only linear railway, also like different branches and going back and all this kind of stuff. And that was exactly the time when I started working for the police, like for the band, because they needed a new bass player. No, I'm just kidding. I'm actually working for the German police, and they had lots of documents, describing their workflows. And this is how all our, this is confidential stuff. Stop reading it. So they had lots of workflows, and they were using like a pseudo diagram language, and the problem was the code didn't match the diagrams, and the diagrams didn't match the code. So I kind of came up, I read about BPMN. I was really intrigued by it. BPMN is the business process modeling notation, and this is the point where, yeah, I'm going enterprise now. So BPMN is a pretty cool thing, like, arbitrary businessman like BPMN. Chuck Norris likes BPMN. Trump always likes BPMN. He's a businessman, so he knows everything about business. So if he likes BPMN, it must be good. Also, DHH likes BPMN. Not. So BPMN is basically a diagram language. You just design processes and activities, and like those diagrams they call activities, and that's how you model your entire workflow in the application, and that goes hand in hand with the event sourcing stuff we were talking about earlier. So basically you have boxes. You have circles, you have arrows, and you have vomiting unicorns. I'm just kidding about the vomiting unicorns, of course, because there's only boxes and circles and arrows in BPMN. And so BPMN allows you to, like, you have like pools, and the pools can talk to each other, and you have like functions where one little box means there's actually a sub-activity being called, and you have like events, so every activity ends in some end event basically, and you can map those end events to other events and to other connections and this kind of stuff. So it's a super cool, a super simple way to model. Why are you laughing? Okay, I thought I said something stupid. So, and you also have like the idea of like throwing events, so you can say, hey, something happened, event sourcing, event DDD, whatever. And you also have catching events, like you can say, tell me if something happened in BPMN. So you basically have a lot of cool mechanics, and I kind of love the idea that I don't have to reinvent a diagram language because it's already there. It's from Java, and people in Ruby community hate Java, but it's kind of like pretty useful. So what we did in 2.1 in Trailblazer is we introduced a new concept called activity, not operation, activity. And activity is basically like an operation, has the exact same behavior. Like you have methods defining the steps or the boxes, and then you have the exact same DSL to define like this is going to be my this is going to be my activity, and it gives you like those diagrams for free basically. And you can have like different ends. So we added like a little bit of DSL. It doesn't really matter, and you can like nest stuff, and it's actually totally like irrelevant how it works, but you can look it up. But you can do this kind of diagrams, which is pretty cool, and you can like map nested diagrams to other nested activities to other activities. Here's again like code, but actually it doesn't really matter because you can look it up online. But the surprising new thing we did in 2.1 was we introduced a concept called workflow. So it's basically the idea of having those little operations defining application-wide workflows. Did I mention that I'm going to be over time? You're the organizer. You should tell me to stop or something like that. Okay, that's good. It's great when the organizer doesn't care. So what you see here, for example, what you see here is a workflow at the police for a one-time password login. Like, people sign up, they get a one-time password, they have to log in with that one-time password. If that one-time password is okay, they have to change their password. They can't do anything else. So that's basically defining that workflow visually. And we're using the exact same concepts again, like every step is just a function that gets input and returns output. So this is just some weird pseudocode I throw in just to show you how those workflows look in Ruby. Like those, and again, like every step can be a callable Ruby object, or it can be a method, or it can be whatever. Like it doesn't really matter. So just to give you a quick example how those workflows actually operate, let's look at this one-time password login. So you usually start a workflow by like triggering a start event, and this will basically run the machine or the process as long as possible until it hits a resume event. Yeah. So this is like, and this is an example how you would do that. Like you trigger workflows, for example, from a controller action. It's not like a fancy thing running in the background. You just change the way you think. In my controller action, I trigger the workflow. This is, again, back to event sourcing. I think we have lots of stuff to talk about later at the pub before I'm drunk. Procedural programming. I love that because it's almost functional. So you trigger that machine, it starts running, executes as much code as possible, and stops at the next suspend event, basically. And every time this machine stops at a resume event, it will give you an event object, and that event object you can persist or you can memorize or whatever. It's up to you. So I threw out all the because I could talk like 45 hours about this stuff. So you trigger something, you run the workflow, and when the workflow finishes, it gives you an event object, and that event object you reuse to continue from that point again. Okay. So, and again, the details are completely irrelevant, like you have an event ID and blah, 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 blah. But what you do is you basically throw events into that process engine, and it will continue the workflow for you where it stopped. It's really interesting. I don't know if you heard of event sourcing, but I hear that it's pretty close to that kind of stuff. So on the process engine will like continue and blah, 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 and go to the next like step and execute everything until it hits another suspend event. And this way, you can model really complex applications. Like at the police, we have, this is just a sign-up process, for example, but we have like, inquiries about people. And so if you have a problem in Germany, just tell me, I can fix it. So we, inquiries about criminal people, or maybe they're not criminal, and we have, like a lot of administrational workflows and all this kind of stuff. So everything in that application was modeled with those kind of workflows, and it works actually pretty well. And the cool thing was that tracing, since we have it in 2.1, it also works. Like it gives you this weird thing, or it just kind of shows you this is what happened. So you can see what happened in my activity and my events, and you can see the flow of the application visually, and that's kind of pretty cool. So the change, or for me, what I extracted as usable components is that we finally could have workflows, and in Ruby you just have like controller actions, and in Rails, and like blah, and something works. Now we have like a building blocks to build workflows. We have you can have parts of your workflow, like an activity, coming from gems. So for example, in Tyrant, which is a replacement for device, you have lots of workflows predefined for you. So like a one-time password sign up is predefined in the Tyrant gem. You don't have to know what it does. It just executes the steps necessary, and you just say, cool, my user is signed up and I have control what's happening. So you have reusable workflow fragments, and you can do that stuff visually, and many other things I couldn't show because I only have 45 minutes and I'm already 6 minutes over time. So my thinking has changed from like using Ruby's mechanics with like modules and objects to let's define little blocks, those boxes, in as callable Ruby code, and let Trailblazer do the workflow execution, basically, yeah? And every block, every task, every box doesn't know shit about the outside world, and the outside world doesn't know what's happening inside. So very functional concepts, because you pass in stuff, you get stuff out. It's really cool. Then the process engine takes care of, running complex workflows for you, and taking care of when is this workflow finished, when is the request over, where do we have to continue. And we got this amazing like visual element that you can trace what happened, that you can visualize what happened. So the police was like super excited. Hey, cool, now we actually see what our code does, and our code does what we see, which is like something that normally doesn't work, because code generators, we learned that 25 years ago, don't work. Yeah. So my entire the last couple of years of my precious life have basically evolved around how do I have small working units of code where I throw in stuff and I get stuff out, and how do I compose those pieces of code into a working software, basically, yeah? And so I realized this is exactly what my dad told me like 25 years ago, because I'm that old, that you build a small component in a big system, and the small component doesn't know anything that happens on the outside. And that is kind of the idea that I kept working on in the last 20 years, more or less, that I it simplifies my life. I don't know what in a sign-up process or in a one-time password process what is happening in step number 5. I just know it does something, and it gives me back a specific output that I'm expecting. And I don't care about the workflow. I don't care about the environment. Like, give me small pieces and I arrange them, and everything else happens automatically. And this is basically the extract of my journey from the last 30 years, that break stuff down to little pieces and let someone else take care of the workflow. And now, I mean, you've been an amazing audience, so thanks for listening to my presentation.
Nick in a nutshell.
I have Twitter, but I don't use it.
Okay. Do you have any questions?
We don't have time. I'm 10 minutes over. Shit.
15.
15? No, my timer says 9 minutes. I'm sorry.
Yeah. I was wondering, have you ever thought about changing the tooling, for instance, because you said that you tried to build your flow, but Ruby didn't help you because of this inheritance, modules, instance, state, etc., etc.
Super.
Yeah, and then you removed all of them and used more like a functional approach. So I was wondering, this is the first thing that came to my mind. Well, maybe I need to change the tooling, for instance, language, for instance, functional language, for instance.
You're right. So so first of all, I'm in the wrong programming language, definitely. But the cool thing about Ruby is you can go to conferences and meet cool people. It doesn't work in other languages, like Haskell. Imagine a Haskell conference, like. And the other thing is that, even in Elixir or something, so I was talking to Jose Valim, the creator of Elixir, and he actually likes the stuff we do, like the workflows, because they also don't have that. They have functions, they are a functional language, they have the pipeline operator, but that's only a linear flow. So they still have the problem, what if method D in ABCD wants to have three outputs? Yeah, how do we handle that? So Elixir doesn't do that. So they also will end up with something pretty close to our, step DSL in a way. So I figured out that as much as I criticize Ruby all the time, because it doesn't move on, the language is probably not going to change yet, because I haven't seen any language with this kind of abstraction of activities and, mapping outputs to different flows, unless you use like either monads and this kind of stuff. But hey, sorry, I'm not a mathematic professor, so I just want to look at code and understand it. So I thought I was wrong in Ruby, but I'm still feeling pretty welcome in a way. A very good question.
Okay. Thank you very much once again.
Thank you.